Welcome to today's webinar, Data Diodes, the one way to protect your most critical assets and networks. My name is Mark Tusant. I'm a senior product manager here at OPSWAT, responsible for the MetaDefender NetWall product family.
And I'm Colin Dunn, Vice President of Products, working with the overall diode portfolio, and in particular, the Fend diode line.
Today, we'll explore how OPSWAT security solutions can stop cyber threats before they infiltrate your network. We'll go in depth about what data diodes and security gateways are, why they're essential for protecting critical assets and networks, a little bit on how they evolved and how they are improved today from diodes in the past. We'll showcase real customer stories, which will help you choose the right diode or gateway for your specific use case.
Well, thanks, Mark. So if you're new to data diodes, or if you need a refresher, we're going to get into a whole lot of the use cases and some of the benefits. But when it comes to what sorts of diodes should you choose, you should definitely consider the MetaDefender optical diode line of products here from OPSWAT, because for several reasons. One, they're simple, they're easy to install. Really, the ease of use is one of the things that we're most proud of, because our customers, whether they need 1 or 1,000 diodes, they're able to do so and get the support that they need. But also be able to do it themselves if they're the kind of customer that wants to take charge. Incredibly secure, using the power of physics to make sure that data goes in only one direction, and we'll talk more about that. And scalable. There's so many different capabilities, protocol support, and different speeds and form factors that you can put these at many different parts across your enterprise. And when it comes to the ability to convert protocols as well, we've got the ability to take data from one format, turn it into another data format, and use that optical break in the middle there to not only have the ability to send data in that physically enforced one-way fashion, but to take data that might be in a legacy format like Modbus and turn it into something useful like MQTT or JSON, and really help modernize some of these systems that might be decades old.
So why do we deploy data diodes and security gateways? Traditionally, firewalls have been used to provide that network segmentation between a high security network and a low security network. But the reality of that is that threat actors see little resistance from firewalls. And a quick search of the web would show you any number of instances whereby firewalls have been hacked and have been vulnerable. Next slide, please. So why is that? Well, firewalls, are fundamentally insufficient to protect critical assets and networks. By nature, firewalls are bidirectional, and they pass routable information between networks. So there's no network confidentiality between a high security network and a low security network. Because firewalls are rules-based, they're prone to human error. And you take a firewall that has 200 rules on it, what's the likelihood that some of those rules have errors in them and are opening up vulnerabilities? But the reality is, historically, some customers in OT environments have air-gapped their OT and IT networks. This is very secure, but it's not practical because the business needs access to real-time operational data. It's critical to business operations. So, it's data diodes provide a way to enable that sharing of data between high security and low security networks and do it in a very secure way. Next, please. Let's talk a little bit about, when we deploy data diodes and security gateways, what are we fundamentally doing? We're providing a secure solution to protect OT networks and OT assets, but we're enabling secure business continuity. And whether that comes from a compliance standpoint, where you have things like NERC-CIP or internal compliance regulations that you need to adhere to, it enables system monitoring so we can understand OT operational status as well as physical security. By enabling data to flow from OT to IT, we enable data analysis. So for operational integrity, looking at things like production capacity, inventory management, predictive analytics, and then finally, supply chain security. How do we securely get files, software updates, patches from a low security IT network into a high security OT network? Colin, why don't you talk a little bit about the traditional Purdue stack and where diodes and gateways fit into the hierarchy here?
Well, absolutely. Thanks, Mark. So, with the OPSWAT line of diodes, you really have a lot more options than you may have in the past. Traditionally, you might put one of these diodes at level 3.5, or really much higher up at sort of the enterprise level, because they were expensive and hard to set up, for, legacy solutions, that is. But now that you've got the ability to deploy these really all over in terms of different data throughputs and form factors, it can be up at level 3.5, but it can also be down at level 1 or 2. You can be monitoring the status of an individual PLC, getting that data directly to the cloud in some instances, and in other cases, having these different layers of security along the way, where you may have smaller air-gapped networks within a larger network that is itself segmented from the outside world. But you have so many different opportunities to do this based on different capabilities, but also different protocols. You might have parts of your network in an industrial setting be speaking Modbus or BACnet. You might be sending syslog or doing FTP transfers elsewhere in the network. The ability to do this with the right diode at the right place is something you can now do. And really, there's a whole family of OPSWAT products for different use cases. There's so many times that we need to make sure that you have that physically enforced one-way data flow. And there are other times where you may need the ability to go grab an acknowledgement, or even grab a piece of data for real-time database replications. So we'll talk about some of the different products in the family here in just a moment here. But these are just some of the different things you need to think about when selecting such a set of products. And our team is here to help make sure that you get all the questions asked that you may have. But really, if you have been shopping for diodes for a long time, and it's been an industry that's been around for decades, the diodes of 10 years ago are really a world away from where they are today, because now you've got so many great options with lower cost, many different use cases that are supported today that just weren't practical or possible before. Lots of different compatibility improvements with different types of networks, not just Ethernet, but also serial and even cellular networks. You might be deploying diodes out in the field that use satellite connections. So many different options today. And of course, ease of use, something you could do yourself. Some of these products can be deployed in 30 seconds. Different form factors, different temperature ranges, might be very hot, very cold, vibration, dusty, different environments that require today's generation of data diodes. And in particular, reliability that continues for years and years to come, living out there with the equipment that these diodes protect. Go ahead, Mark.
So we're going to talk a little bit about some of the individual product lines and some of the use cases that they're deployed for. And as Colin referred to earlier, we have a broad portfolio range of products to really align the best solution with your particular use case. Next slide, please. So first off is our optical diode. This is a server-based rack mount product. It provides hardware-enforced unidirectional data flow. It is governed by the rules of physics, and there is no return path on the optical diode. It's a multi-purpose device, meaning we can run multiple simultaneous data flows using different protocols. The solution is very scalable. The solutions that start on the rack server here at 100 megabits per second, upgradable to 1 gigabyte. And then we offer server-based, enterprise server-based solutions that can scale up to 10 gig. Our optical diode, as well as our security gateway, are common criteria EAL4 plus certified, and these devices support high availability. High availability is increasingly becoming more and more important to customers that purchase data diodes. Next, please. We have a range of optical diode DIN rail mount devices. This particular device is available at 10 megabits per second or 50. It is a multi-purpose device. And importantly, this is the industry's first C1D2 certified optical diode, which means that the product is suitable for use in environments like oil and gas and chemical processing, where you have volatile environments, and you need to ensure that that device is not capable of setting off a spark that could cause an explosion and harm to workers. And again, this device is also common criteria EAL4 plus. Colin's going to talk a little bit more about the Fend product line. And Colin, go ahead, please.
All right. Well, thank you, Mark. So the Fend product line joined the OPSWAT family recently, and it's exciting in that it expands the use cases for data diodes out to the edge. And at times we're protecting very small networks, including individual pieces of equipment. That might be very important pieces of equipment, but out in the middle of nowhere, and it might be an expensive truck roll to go check on that piece of equipment that might otherwise want to live behind an air gap. But also sending log files, sending other sets of information at more of an enterprise scale. So many different types of use cases, particularly in legacy environments. There's a fanless design, a very low power consumption, very wide range of temperatures, and all of them support Ethernet. They also support serial connections on the input side. We have models that have serial on the output side as well, but it's a single box, completely isolated from the input and the output side, optically isolated, electrically isolated. That means you can put diodes into equipment cabinets and other places where it might otherwise be a tight fit. They're also designed to be rugged and affordable, so that you can put these out by the dozen, by the hundreds, and have a consistent approach to network segmentation. A variation on this model is also the optical diode with cellular connectivity, the Fend CE, where it allows you to take data into this into the device via serial or Ethernet and convert that data into a different format, whether it's Modbus in and MQTT out, for example, and send that data over cellular networks. So you can now get data out of some of these systems that you may not have fiber there. You might not want to go dig a trench. Being able to use that ever-present cellular network, but pulling data into those environments where you might otherwise find that to be a security concern, this still has the full optical isolation, the full protection of that system, but you can get the data out and send it to teams so that they can know, do I need to be out there today? Can I save a truck roll, or should I be sending out a person with the right tool at the right time? All empowered by the cellular connectivity. Go ahead, Mark.
Okay, thanks, Colin. So we've covered our line of optical diodes, and I'm going to talk now a little bit about our security gateways, because to refer back to the beginning of the presentation, we talked about different solutions are required for different use cases. Skip forward, please. And so the first is our unidirectional security gateway. The security gateway enforces unidirectional data flow over a protocol break. The difference with this product is it offers guaranteed data delivery. So the nature of a data diode, because there is no return path, because it is hardware enforced, governed by the laws of physics, there is no return path. With a diode, and this is not just OPSWAT diodes, this is all data diodes. If you have a network IT outage, the blue side, which is typically in the OT network, has no way of knowing that you've had a network outage on the red or the IT network. And so, potentially after your buffers fill, you could lose data. For many customers, that's a non-issue. It's not a large concern. For certain customers in certain use cases, they want to ensure that if they have network outages, they never lose data. So the unidirectional security gateway enforces that unidirectional data flow, but returns a very small proprietary acknowledgement back to the red side, and then the blue side reaches out and pulls that acknowledgement back. Now, the security profile of this is that it enforces unidirectional data flow, but only blue can initiate a connection. Only blue can initiate the unidirectional data flow. Only blue can initiate a get to pull that acknowledgement back to the blue side so that, if we have an outage, we can close a TCP connection and then retransmit. Like our optical diode, these are multi-purpose devices, scalable, different range of bandwidths, support high availability, and the user interfaces are 97% identical between the diode and the gateway. Next, please. Our bilateral security gateway is deployed in use cases that cannot be converted to one way because they require a data response. And a good example of this is Microsoft SQL replication. Historically, on large, very active databases, data diodes are challenged with keeping the source and the destination or IT database in sync. And the reason it is that once you have a network outage, either on your blue side or on your red side, you're automatically out of sync. So our bilateral security gateway was designed to handle data responses, and it works very much in the way that the unidirectional security gateway works, in that we move data from blue to red unidirectionally. We have the capability to return data responses to the memory segment on the red side, and then the blue side reaches out and pulls those back. Again, red has no ability to initiate or write to the blue side. Only the blue side can initiate a connection. Next, please. And last but not least is our transfer guard with file sanitization. And this product is designed typically for moving files from a low security network into a high security network. And from the OT context, typically these are operational files, software updates, patches that you need to securely move into a high security network. And what we do is we take our optical diode and then we layer on our MD Core file sanitization technology. So we can do things like scan on 20 different simultaneous AV engines. We can do content disarm and reconstruct to fully sanitize those files to ensure that only known good files are sent across that OT boundary. Next, please.
So we're going to go through and talk about some different use cases for diodes and some of the different product lines that we talked about just a few moments ago. But we'll start with some of the Fend use cases, and really these diodes are in places now that never would have been practical for diodes in the past. But when it comes down to it, all infrastructure is critical to someone, and if it's something worth protecting, if it's something that really you can't afford to live without, and it's equipment that really otherwise wants to live behind an air gap, or the threat of attack and the outcomes are such that you can't afford to live without their protection, that's a really great set of use cases for the Fend product line, and really the sort of thinking you should be applying to any one of the NetWall products as well. But in terms of sort of distributed defense, I'll give you an example of one of our customers. Is a beach town up in New England. And really, this beach was critical to the operation of the town. It was a tourist-based economy, and really they had a choice to make. Do you want to have tourists at the beach, or do you want to have the local sewer system overflow onto the beach? You can really pick one or the other, and if they get together, usually the sewage wins out, and you don't wind up having that key set of visitors because, well, frankly, nobody wants to be there for this sort of a mess. But why are we talking about that sort of a choice? Well, this particular customer had pumping stations all around town that they needed to keep an eye on. And their neighboring town actually had a cyber attack that had them lose visibility into their overflow protection systems. And what they wind up with, they had the risk of that very scenario we just saw, where you had to make that choice and the wrong choice was made because that investment hadn't been made in cybersecurity. So what did this customer decide to do? Well, they needed to improve a system that they had, and this was a great time to put in additional cybersecurity and really make it a more practical system. as is often the case with infrastructure improvement projects, you've got to be in at the right time. And in this case, they had an aging radio tower that needed to be decommissioned. They were getting this data from each of the pumping stations. What is the status of the wells? What is the sort of key telemetry that the Department of Public Works would need to know to operate these? Well, they weren't going to be able to get this data via the radio anymore, but they also had the challenge that they weren't really doing much with that data from a visualization standpoint. And so they said, what solution can we do to help modernize the way we use and obtain that data, but also improve the cybersecurity? And what they wound up going with is putting one of our cellular data diodes at each one of these pumping stations. And they had more than a dozen of them. And that meant that they could now get that data out of these systems, which again are all over town. They didn't have data connections there. They were using that radio system they couldn't use anymore. And they were able to send that data with our help directly to the cloud and get that data on their phones and on their desktops for the first time and really be able to see, do I need to send somebody out there today? Or is this the sort of thing where I can use that maintenance resource to do something else? And it's really a powerful way for them to improve operations and cybersecurity at the same time using these cellular enabled data diodes. Another example is really based on cost savings. And can we take streams of data that might otherwise be out of reach and turn them into opportunities to save? And this particular customer, big manufacturing company, nearly 60,000 employees, and they have at each of their factories, and they had many of these factories, massive air compressors. And these are the sorts of pieces of equipment that if it goes out of tune, even just by a little bit, for a few hours, you could be talking thousands of dollars in wasted energy. And so what they needed to do was say, hey, can I get this data to experts that were really centralized elsewhere in the world, but get this information from plants and say, are there opportunities to make changes quickly so that we aren't turning money literally into hot air? But can we do that in such a way that's comfortable for the cybersecurity policies we have for our factory floors? And the policy typically was nothing gets to touch the factory floor from the outside world. Well, this sort of project to get this real-time visibility was taking them years to figure out until they found us and we presented how the technology works, how you have that physically enforced connection in a one-way fashion that allows you to get data from the factory floor off to the cloud and have the cloud tell those operators what they should be doing, but not give the power of the direct connection to the factory floor to any of those cloud-based systems. And they were very comfortable with this hybrid approach of data analytics tells the team what to do, the team makes changes, and then the data is fed back out through the diodes. What it means is that now they can get this information in near real time. They can make those changes. They can save energy. They can improve reliability. And very importantly, help prevent an outage at a plant, which billion-dollar plants that could be millions of dollars a day in downtime, they get to avoid, all thanks to these industrial data diodes. Go ahead, Mark.
Okay. I'd like to talk about another customer use case, a very large liquid natural gas provider, $7 billion annual revenue, 1,000 employees. They came to us with a challenge. They wanted to isolate and secure their OT assets. Like I stated earlier in the presentation, they wanted to secure their assets, but needed to enable business visibility and continuity via remote monitoring. They also had a concern that they wanted to minimize downtime and any loss in data in the event that they had a hardware or a power or a network connectivity failure. So those were the challenges that were brought to us. And next slide, please. So what we did is we recommended our optical diode solution and deployed the solution in with two appliances in a high availability configuration. This met their requirement that they could gain access to that valuable OT data and securely transfer it to their IT networks for business analytics. And then the high availability configuration provided assurance that in the event of a hardware failure, a network outage, or a power failure, that that data would not stop flowing. Next, please. So the outcome, we provided them with the hardware enforced unidirectional data flow, isolated the OT network from the IT network. They had their OT data available for remote monitoring, and were confident and comfortable that in the event of an outage, they would minimize downtime. Next, please. Another use case, we have a large natural gas provider, 12 billion in annual revenue, 3,500 employees. They came to us with a similar requirement, but they wanted to isolate and secure their Aviva Pi database. Now, the Aviva Pi historian is very often one of the first use cases that customers bring to us to secure. And why is that? Because really the Aviva Pi database is an aggregator of many types of data into a centralized, time series database. And if that were to get knocked out in an attack, the business would be put in a very bad place. Essentially be operating blindly from the OT perspective. The reality of it is that they need to replicate that data out of OT into IT. And so this is a very common use case for us where we're replicating Aviva Pi data from OT to IT. They also had the requirement that they wanted to minimize, much like the previous customer, minimize downtime and loss of data in the event of a hardware or network failure. Next, please. So we recommended, they opted to choose the unidirectional security gateway over a data diode. And as I mentioned earlier, this concept of guaranteed data delivery was attractive to the customer as another level of assurance that in the event that something goes wrong, they're never going to lose data. So we deployed the unidirectional security gateway in a high availability configuration, along with our MetaDefender Aviva Pi connector to integrate with the Aviva Pi database and facilitate the movement of that data securely from OT to IT. Next, please. So, the outcome is they were able to securely replicate that Pi database. A lot of assurance that we provided a secure solution, and then they're wanting to minimize downtime in the event that they had some sort of failure in the equipment or on their network with the high availability configuration. Next, please. Last but not least, I want to talk about a large municipal water authority. They service about almost 1.5 million people. And they came to us with a challenge. They wanted to securely replicate a large, very active Microsoft SQL database. And they wanted to ensure synchronization between the source and destination database. And if you recall earlier in the presentation, I talked about some of the challenges of doing large active SQL databases over a data diode because you don't have that feedback mechanism. If you have a small database, you can do this with a file transfer over one of our devices, but often these very large, very active databases require a different type of solution. So their goal was, again, to securely replicate that data, ensure that both source and destination database stay in synchronization, and like the previous use cases, they wanted to maximize uptime with a high availability solution. Next, please. So we recommended our bilateral security gateway, which was deployed with 2 appliances in a high availability configuration with 10 gigabit hardware. And the outcome is that we achieved their goals. They were able to obtain the level of security that they required. They're able to be sure that the databases will not become out of sync in the event that you have an outage, and as well as they have 2 appliances in a high availability configuration to provide that uptime assurance that they required. Next, please. Okay. Next, please. Last, we have a government ministry, and this is a little bit different use case because many of the OT use cases are for moving data from a high security network to a low security network. But this is an opportunity where the challenge was to enforce air gap level network security while ensuring that malicious files are blocked from entering the high security network. Next, please. So we recommended our MetaDefender transfer guard solution integrated with our MD Core file sanitization tools to provide things like multi-AV scanning engines. Like I said earlier, we can run up to 20 Linux-based AV engines simultaneously on the device and do other sanitization things like deep content disarm and reconstruct to ensure that only known good files are moved across that network boundary. This brings us to the conclusion of today's webinar. If you have any additional questions, please type them into the chat and we will promptly respond. Again, thank you for joining today's webinar. We appreciate your time. There is a QR code on the bottom of the screen that you can scan if you'd like to speak with someone at OPSWAT and/or again, send us a note in the chat and we will respond. Thanks again for your time. Have a good afternoon.